Okay, so this is the SAT, official SAT exams, exam 1, section 3. This is the math no calculator section. So let's get started. Question 1. If x minus 1 over 3 equals k and k equals 3, what is the value of x? So for this question, we have k equals 3, so we plug that in here. So we get x minus 1 over 3 equals 3. So first step here is we need to remove this 3 because we're isolating for x. So we move it to this side. Since it's a factor, it can be moved diagonally, right? So then we get rid of this. We get x minus 1 equals 9. Then we have the 1 here, so we add 1 to both sides. And since that's a term, it could be moved to the other side via the opposite operation. And we get x equals 10. So that's choice D. Question 2. For I equals square root of negative 1, what is the sum of 7 plus 3i plus negative 8 plus 9i? So the best thing to do here is to stack these up, and we'll add the real parts and add the imaginary parts. So we're combining 7 with negative 8. Since these have different signs, it's a battle, and the negative team wins the battle, and they win by 1 point. These are the same signs, so they add up to 12i. So that's answer choice A. Next, on Saturday afternoon, Armand sent M text messages each hour for 5 hours. So that's M texts per hour and 5 hours. Okay. Tyrone sent P text messages per hour, P texts per hour, for a total of 4 hours. Okay. Which of the following represents the total number of messages sent by both? So we would just have to add these up. So we get 5m plus 4p. Now the reason why I set it up this way is that so the hours cancels out. Right? If I was to multiply these, the unit of hours would cancel. And I would get 5m texts. So this is the number of texts that the first person sent, which is Tyrone. And this is the number of texts that were sent by, the first person is Armand, and this is Tyrone. But you get the idea. 5m plus 4p would be the total. Choice C. Question 4. Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation this. P is the number of phones, D is the number of days she has worked that week. What is the meaning of the 108 in this equation? So this is a linear function. We know it's linear because it's of the form y equals mx plus b, where m is the slope and b is the y-intercept. So we can interpret this negative 23 as the slope, and this value here, 108, is going to be our y-intercept. So we interpret 108 as the y-intercept, which oftentimes that will mean that it's our starting point. Okay. So in this case, it's the starting point for P, where P is the number of phones left. So that is the initial amount of phones. Okay. Before you've completed any of your assignment. Okay. So let's see. So it's a number of phones, not a number of days. So A is out. Starts the week with 108 phones to fix. That's a very strong candidate. Repairs phones at a rate of 108 per hour. So this, notice the unit would be phones per hour, which is a rate which we would see for the slope, not for the y-intercept. Repairs phones at a rate of 108 per day. So yeah, this is actually more like what we would see for the slope, since it has the right time unit here. But again, that is not what we're looking for. So answer choice B is correct. Question 5. Okay, so we just have to compute this by distributing the minus sign first. And it goes to each piece of this second portion. So I'm just going to rewrite the first part. X squared y minus 3y squared plus 5xy squared. Then I'm going to distribute the minus sign, switching every single sign here. So that will give me plus x squared y, and then minus 3xy squared. And actually, what I'd like to do is I'd like to line this up with this one here. Whoops, the minus didn't go with it, so I'll just move that. Okay, because those are like terms. And then, of course, I have to bring the minus in for the last one, which would be plus 3y squared, and I'll put that here. Right, so they were a little bit tricky with that. We'd have to switch those. Okay, so now we just add vertically. We have x squared y and another x squared y. That gives me 2x squared y. This middle term will cancel out. And then I have a plus 5 combining with a minus 3, so that gives me plus 2 of the xy squareds. Okay. So that looks like answer choice C. Next, pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age a in years between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? So effectively, right, we're looking for the number of inches per year that the person grows. And as we could tell, this is a rate, or in particular, rate of change. And that's a fancy word for slope. So what we're effectively trying to do is to find the slope of this, which is a linear function. Right? So if we have a linear equation, the slope is always going to be before the independent variable. So this would be our slope. Our slope is 3. And if we think about what the units would be, well, h is height, which is measured in inches. And what was a again? Yes, a is in years. So inches per year. Because we remember slope is always change in y over change in x. In this case, y corresponds with height. So change in height. And x corresponds with years. So change in time. H measured in inches and y, or t rather, is measured in years. So this is exactly the right prescription for our answer, choice A. Next, question 7. Okay, so this one looks scary, but I promise it's not as bad as it looks. The formula above gives the monthly payment M needed to pay off a loan of P dollars at R% annual interest over N months. Which of the following gives P in terms of N, R, and N? So basically they want you to isolate P. Isolate P. And P is right here. So P, notice, is a factor. And I hate when they put it in the middle here. I'd rather if they put it on the top, where it belongs, right? Because there's no such thing as middle. So, really all we have to do, and again, I don't like middle, so this bothers me. Okay. All we have to do is isolate P, and effectively we have to get rid of everything else, put it onto the other side. Okay. And we notice that anytime we have a binomial situation, we always put it in parentheses. So this can be thought of as two separate terms. So I would put a big bracket here. And my first move would be to take this entire denominator and to move it up next to this m. Because collectively, this whole thing is a factor, and factors get moved diagonally. Okay, so that's my first move. I'll just rewrite everything that was there. R over 1200, and that goes to the power n. And then we minus 1. Okay, so now it's gone from here. So we could just disregard this piece. Next, we have to remove both of these factors from the numerator. And since they move diagonally, right, this is going to move down to the bottom. Okay, so we get R over 1200. Right, that's a factor. And similarly, the other factor also moves diagonally down to the bottom of the other side of the equation. So we end up with 1 plus R over 1200, all to the power n. Okay, so we've effectively moved these to the other side, and therefore we've effectively isolated P. And this is going to be our result. Okay, so let's see which choice matches that. It's not A, because we want this in the bottom, right? Let's see. B looks promising, because it starts out with the correct piece here, with the minus 1. Then it has M, and again it writes it in this very frustrating way, but it is in the numerator effectively. And the denominator has the two correct pieces. So yes, B is correct.